Welcome students, myself Professor Ravinder Jain and you are watching my lecture on old quantum mechanics and photon. This is part 2 of my lecture on old quantum mechanics. In this lecture, I will discuss the concept of photon and the photoelectric effect. The concept of photon was given by Max Planck in 1900. According to Max Planck, energy is emitted or absorbed by a matter in discrete packets, and these discrete packets are also called quanta or quanta. This discrete packet or quanta, they consist particles, and these particles are photons. Therefore, photon is a quantum of electromagnetic energy. Or photon is a packet of electromagnetic energy. This packet will consist of energy E as h nu, 2h nu, 3h nu, like this nh nu. I mean as integral multiple of h nu. Now I will discuss some properties of photons. First property I write here, photon is a packet of energy. Which I mentioned earlier also. Second property I write, each photon has energy h nu, where h is the Planck constant and nu is the frequency of the radiation. Third one is, a photon behaves like a particle also. Of zero rest mass. That is, the rest mass of this photon is 0. Otherwise, as E is equal to h nu, and this is also equal to mc square, where the m is mass of the photon, its rest mass is 0, but otherwise its mass is given by E upon c square, h nu upon c square. This is hc by lambda c square. Since nu frequency is c by lambda c by lambda, lambda is the wavelength. So this becomes h upon lambda c. As photon has mass, it will have momentum also, and its momentum is given by P is equal to mc. We know that momentum is mass into velocity. So here it is m into c, since photon travels with speed of light. This is also written as m c square by c. mc square is E energy, this is E by c. This is E is h nu, this is h nu by c. And this also becomes equal to h by lambda. And the last one is photons are electrically neutral. They are neutral particles, are electrically neutral, and hence not deflected by or affected by, and hence not affected by electric and magnetic field. Photons are not affected by electric and magnetic field since they are neutral particles. Students, I have discussed what is a photon. Okay, it is a quantum of electromagnetic energy. And what are the properties of photons? Okay, these are some properties of photons. Right? Now I will discuss photoelectric effect. What is photoelectric effect? I write the statement: when light is electromagnetic radiation, it means photons. When light of suitable frequency is incident over the surface of a metal, and electrons are ejected, from the surface of metal, this phenomena is called photoelectric effect. Let this is some metal surface and the light is incident over it of frequency h nu and energy h nu. The frequency is nu and the energy is h nu. And if electrons are ejected from it, from the surface of this, okay, then this is photoelectric effect. And the main important thing in this phenomena is that this frequency should be suitable, or this energy should be suitable. It means that photoelectric effect is not possible with any value of energy. A suitable value of energy is required. Right? Okay? The minimum value of frequency, required to cause the photoelectric effect, is called threshold frequency. And it is written as nu not this 0 is put as subscript here. It means that if this frequency is greater than equal to nu naught, photoelectric effect is possible. It is okay. And if this frequency nu of incident photon is less than threshold frequency, then photoelectric effect is not possible. Okay? So, some minimum frequency is required to cause the photoelectric effect, and that minimum frequency is threshold frequency. There are some observations on photoelectric effect, and these observations are: number one is the number of electrons ejected. The number of electrons ejected, we will call them photoelectrons. Photoelectrons depends on intensity of light, of the light incident and not on the frequency. As we know that the intensity of light depends on number of photons. Number of photons. More intensity means there are more number of photons. If there are more number of photons, then more number of photoelectrons will be ejected. Since one photon eject out one electron, if there are 3 photons, 3 photoelectrons will be ejected. Okay? So, if intensity increases, it means number of photoelectrons will increase. And the second observation is speed or kinetic energy of photoelectron. Depends on frequency and not on the intensity. Students, carefully read these 2 points. Number of electrons ejected depends on intensity and not on the frequency. And here it is reverse. Speed or kinetic energy of photoelectrons depends on frequency and not on the intensity. These 2 observations were well explained by Einstein in 1905, and Einstein used the concept of photon of Max Planck. Let this h nu, this is incident energy. This is incident energy. H nu naught. This is the minimum energy required to cause the photoelectric effect, and this is called threshold energy. This minimum energy is called threshold energy, or this is also called work function. This is also called work function, and it is denoted by phi naught. Here this nu naught is the threshold frequency. Then according to Einstein's photoelectric equation, Einstein's equation on photoelectric effect, this h nu is equal to h nu naught plus maximum kinetic energy Students, this Einstein's equation on photoelectric effect is simply energy balance equation. Let me explain it. Suppose 3 electron volt of energy is required for photoelectric effect. I mean, this h nu naught is 3 electron volt, and the energy incident over the surface of metal is 5 electron volt. Okay, that is 5 electron volt is incident and 3 is required. So what about the difference of these two? 5 minus 3 means 2 electron volt. This 2 electron volt will be the kinetic energy carried by the photoelectron. Students, you can see here, this 5 electron volt of energy is incident over the surface of this metal, and the required energy for photon electric effect is 3 electron volt. So 3 electron volt, this much energy is required to eject out the photoelectron. So what about this 2 electron volt? This 2 electron volt of energy is carried by electron. This is photoelectron. Okay. And I have written it, this is the maximum kinetic energy. The kinetic energy carried by photoelectron, this will be maximum. If the electron is coming from interior of the metal surface, suppose it is coming from here, this may carry energy less than 2 electron volt. If it is coming from the surface of the metal, then it will be 2 electron volt. I have shown here from here, but it might be coming from surface of metal. This I put equation number 1. Then this maximum kinetic energy carried by the photoelectron is equal to h nu minus h nu naught. It is difference of incident energy and required energy, and this is equation number 2. Or as the kinetic energy is half mv square max, this is maximum, this becomes equal to h nu minus h nu naught. M is mass of photoelectron and this V is speed of photoelectron. This is our equation number 3. Now I discuss some cases. First, if this incident frequency nu is equal to nu naught, then this maximum kinetic energy will be equal to 0. It means that if the incident energy is equal to required energy, the photoelectron will just eject out from the surface of metal, but it will not leave the surface of metal, since its kinetic energy is 0. Again listen, if the incident energy or incident frequency is equal to required energy, photoelectron will be ejected, but it will not leave the surface, since its kinetic energy is 0. Second point is, if this nu is greater than nu naught, this maximum kinetic energy, this will be some positive quantity. If this nu is greater than nu naught, this maximum kinetic energy is positive. It means the photoelectron will come out from surface of metal with certain energy. And the last one is, if this incident frequency is less than required frequency, threshold frequency, then this maximum kinetic energy, if this nu is less than nu naught, this will be negative, or this half mv square will be negative, or it means v square is negative, or this v is imaginary. I mean the speed of photoelectron is imaginary. If the speed of photoelectron is imaginary, it means there will be no photoelectric effect. Okay? There will be no photoelectric effect. And this is the basic concept which I discussed earlier, that if the frequency is less than threshold frequency, there will be no photoelectric effect. A minimum frequency is certainly required to cause the photoelectric effect, and that is nu naught. Okay? Students, you can see from this equation easily that this maximum kinetic energy depends on the frequency of incident light. Since this work function is fixed for a metal, every metal has its fixed work function. Okay, so this is constant for a metal. Then maximum kinetic energy depends on frequency, and this was our observation also, which I have written here, that the speed or kinetic energy of photoelectron depends on frequency. Okay, so this observation was well explained by Einstein, and it will not depend on the intensity. Okay, since here is no mention of number of photons, so maximum kinetic energy depends on frequency only. Okay, now I will discuss why classical mechanics or classical theory, which is electromagnetic wave theory, could not explain photoelectric effect. I mean failure of classical mechanics, failure of classical electromagnetic theory, to explain photoelectric effect. There are certain causes due to which classical electromagnetic theory could not explain photoelectric effect, and these causes reasons are, number one is, right here, number one, let light of energy h nu, which is less than the required energy h nu naught, is incident over the surface of this metal. Okay, as we know that the photoelectric effect is not possible in this case, there will be no photoelectron ejected. But the classical theory says that although the energy is less than the required, no doubt, but this metallic surface will go on absorbing this energy h nu, and as this process continues, the level of energy will increase within this metal, and it may reach to h nu naught. Okay, I mean, suppose this required energy is 6 electron volt and the incident energy is 2 electron volt. Okay, but this metallic surface will go on absorbing this energy. Initially it has absorbed 2. The process is in continuous. This level will increase after some time to 3. Then it will be 4, 5 and 6. When it reaches 6, there should be some ejection of photoelectron. But actually there was no ejection of photoelectron. There is no ejection of photoelectron in this case. So classical idea was wrongly interpreted here. classical idea says there should be ejection of photoelectron, but actually there is no ejection of photoelectron in this case. Okay, so classical idea fails here. According to that, if the energy is less than the threshold, there is possibility of ejection of photoelectron. Okay. Second is photoelectric effect is instantaneous. I mean, as soon as the energy is incident, the photoelectrons will eject out immediately. Instantaneous means immediately. But in this case, when the energy is less than the required, classical theory says there will be ejection of photoelectron after some time. But practically, it never happened that electrons are ejecting after some time. If electrons eject, they will eject instantaneously. Okay, so classical theory fails here also. And the third reason for failure of classical theory is, classical theory says that if more number of photons are incident, I mean E is equal to NH nu, N is the number of photons. If high energy is incident, means more number of photons, high energy means here, it is not high frequency, it is more number of photons. If more number of photons are incident on this surface, this N is large, these more number of photons will exert more force or pressure on the electrons of this metal, and this more pressure will eject out the electrons. This more pressure will eject out the electrons. It means by increasing number of photons, there may be photoelectric effect, but this is also wrong, since photoelectric effect does not depend on intensity. It does not depend on number of photons. Number of photons means intensity. Photoelectric effect does not depend on intensity or number of photons. It depends on frequency only. Okay, so this is also cause of failure of classical theory. Students, now I think that you are well aware that classical theory is not competent to explain the photoelectric effect. The photoelectric effect was well explained by quantum theory given by Max Planck, and the idea of Max Planck was used by Einstein to explain the observations of photoelectric effect. Thank you very much. I hope you enjoyed my lecture, and wait for my part 3. This is part 2. Part 3, part 4, okay, to study the further concepts of old quantum theory. And in next part 3, I will discuss Compton effect. Okay, thank you very much.